I guess.
Okay, let's start. Hi, everyone. Thank you for joining this presentation. So I am Samuel Garcia from Lyon, and I let present my other colleagues, Alessio, Alberto, and Chris. You can present.
Hi everyone, my name is Alessio Buccino. I'm for the Allen Institute for Neural Dynamics, and I'm one of the co-developer of the SpikeInterface-GUI. And then we have here also Chris and Alberto, if you want to quickly introduce yourself.
Okay.
Sure. Hi, I'm Chris. I'm at the Uni of Edinburgh, and I spend some time developing Spike Interface, and it's great.
Hey everyone, I'm Alberto and I work for Catalyst Neuron. So I'm also working as a developer of Spike Interface. So nice to meet you all.
Okay, cool. So the main idea is, so the meeting is recorded, so you can enter and leave when you want, and you will be able to check it. And we have a YouTube channel, and we will post a video on it if you want to leave before. So the idea, we will present Alessio and me mainly, and Alberto and Chris will help us with the question and animate a bit the presentation. So let's start now. I put this in main screen.
Yeah, maybe before starting, to all the attendees, if you have a question, you see at the bottom, you should have a Q&A. So you just post it there, and some of us will either reply there or at the end of the presentation ask you if you want to come on stage and ask your question, or we'll find a way. So let's get started.
There's a way to put you on the speaker side. Okay. Well, the main idea is to present this project, SpikeInterface-GUI, which is inside the SpikeInterface ecosystem. And before this, maybe most of you are already familiar with SpikeInterface itself, or the project itself. We have a 1 hour or 2 hour presentation you can look on YouTube if you don't know the project yet. But this slide is to present what is SpikeInterface. In short, it's a project written in Python to be able to make for you spike sorting pipelines. In short, we have all the machinery to read the data, many formats, to make fancy pre-processing. So with simple Python function. So here it's a simple stuff. You want to filter your signal, but we have very complex one until motion correction or artifact removal, or we have many machinery to do it with the pipeline. As well, we have many formats. And so the idea is to construct a pipeline simple with a few lines of codes. You can run a sorter directly. So we have some kind of wrappers on top of many sorters. For instance, if you want to run kilosort, you just do this. If you want to run kilosort 2.5, which is a MATLAB-based sorter, we have some machinery to either run MATLAB in the background or to download the Docker image and to make the machinery happen very transparently. So it's super easy to run many softwares that will handle your spike sorting problems with a few lines of codes. And a bit more recently, 1 year or 2 years ago, we introduced this new object, which is what we call the post-processing. So after you get your spikes and spike trains from the sorter, you can combine the results, your sorting object, which is the result, your spikes, and the recording. And it's what we call an analyzer. And this mix these two objects, which is our first object to make some computation and make the curation, the post-processing and everything. So today, if you use SpikeInterface, the main stuff is to understand a bit more of this. And it's what we present very briefly. So the idea is you combine the recording and the sorting. This object is quite flexible. It can be in memory, on disk, or remotely on a bucket if you want to store stuff on the cloud. We have several formats, one which is ZAR-based and one which is NumPy-based. It's detailed, but it's flexible and hackable. It's easy to understand. And the main concept is inside an analyzer, we have some extension, which is something you want to compute after the sorting. And the main idea of this is to be totally sorter agnostic. In short, many sorters give you already many results in the output folders. For instance, KiloSort can give you some good or bad units you have, or spiking circuits do the same and MediSorter do the same. But the idea is to have a unique object that from the sorting, you can compute extension. For instance, the template, the waveform, some corollograms, some quality metrics. And all of this computation, it's what we call an extension. So it's flexible and we could make more and more extension inside the analyzer. And of course, all the plottings we have in SpikeInterface to check the quality of your sorting is based not on the sorting, the spike only, but it's the analyzer that combine both the sorting and the traces, the recording itself. We have to have this in mind. And then the good stuff is when you have your analyzer, we have many plotting layers which are already available in SpikeInterface. So the historical one is to plot everything with matplotlib, so you can make figures to show some result of your and the quality of your units, to check waveforms or cross-coronogram. We have a similar stuff which is based on PyWidget, which is cool because you can integrate this directly in Jupyter if you want to make some dynamic and interactive session directly in Jupyter. Jeremy Magland, a few years ago, wrote some things that directly push all the results somewhere in the cloud in a specific format, which is based on FigureRL. And then you have a full access to part of the results directly in the web. Everything is based in JavaScript. You don't have access to everything, but you have access to many stuff. So it's a technology that pushes a sub-part of the results, and then you are able to retrieve directly without any installations. And then the third way is what we will present today, which is SpikeInterface-GUI, which have two sides, which is what we will present, which is another view, and that could be a replacement of on top of it to replace file, for instance. So it's what we will present today. Voilà. Importantly, before the presentation, we need to present something which is pretty new, which was built on top of the analyzer, which is the curation. Because of course, you certainly know that after running KiloSort 4, you have stuff to do, either automatically, either manually, to remove bad units based on some criterion, or to merge some of units, or to split some units. You have many stuff to do automatically or manually. There's more or less three ways to do it in SpikeInterface. The first way, which is the most simple, is to put some rules on top of your quality metrics to filter what is a good or a bad units. And you can do it in 1 or 2 lines of code. I don't show it today, but it's the historical way of dealing with bad and good units, or MUA, or what you want. More recently, people from the SpikeInterface team work a lot in a tool which is auto-merging, so make automatically merges based on some criteria. So Aurélien Vignard, Alessio Buccino, Pierre Iger, and a bit of me work a lot on this. So we have an internal tool based on the sorting analyzer and mixing many information. You can make some auto merges. And also from other teams, so Anushka and Chris and many people from the team made some make some classifier based on many criterion to classify, and then you can get for free with some models available on Hugging Face to apply these models on your dataset, and you get some pre-trained labels, and then you can check it. So it's another way to make your clean. And today what we will show is the manual curation, because even after this and this, maybe you want to check and manually remove or merge some cells because you always still have mistakes. And it's the main goal of the presentation of today. Okay, so you have this is these two functions, auto merge unit or auto label units. All the machinery is available in the documentation. So for the curation, what we did, so we met last year in Edinburgh for a hackathon, the team, and we decided to make a format that could describe what is a curation. In short, you have a result, and I want to make some curation. So we decided it's a simple dictionary to decide how to describe a creation format. In short, to not apply in place, but to keep a trace of the creation I did. So it's pretty simple. We have a version definition. We are working on the version 2, which I'm presenting here. You have the units, you have the definition of the labels, and then this part is what I did me to create my stuff. So up here, you have an example that you can manually label this unit as good, this unit 2 as noise, and you can have some extra label when you can combine several. I want merge this, and this, and to remove this. So it's a description with a simple dictionary that you can store to JSON. And this is good because when you do creation, if you keep this file, which is super small, you can come back to the creation you did. In short, you keep trace of your creation, and we propose this curation formats, and it's in discussion to make more version to improve the format along the way, keeping the backward compatibility. And so the idea is when you have an analyzer and you want to create something, we have internal method I have an analyzer and I want to remove units. And internally, the analyzer handle the fact that it copy-paste the data and remove some units, which is an important detail because it avoids you to recompute the entire analyzer. For instance, I have all the templates. If I want to remove 3 units, I remove 3 lines in the matrix. It's super fast, and it's what it's doing. We have the same machinery for merging, which is a bit more complex. In short, when you have an analyzer and you want to apply some merges, we have fast or slow way to make the new analyzer that reduce the unit list and recompute the new extension based on the merging rules you give. And we have this machinery. And if you combine these two stuff, which is remove and merge, it's more or less what we do with the format. In short, you have a curation format, which is a list of remove, merges, labels. We are working on splitting, which is not done yet. You have your formats, I presented here. You store it in a JSON stuff, which is a dictionary, and you apply it, and you obtain an analyzer clean. So the workflow, so before the workflow, before presenting the main workflow, it's this. So SpikeInterface of history used to be the 3D clue GUI I did a long time ago. Then I ported it, the entire GUI on top of SpikeInterface and the sorting analyzer. I think very few people used it. And it used to be a viewer only with no curation. And after the new curation format, what we did is to integrate some curation inside this GUI with few efforts. And more recently, the great Alessio Buttino make an enormous work to duplicate this GUI into a web app, and that we will present today. So I go back to the curation pipeline stuff. In short, the idea is after you pipeline, you compute an analyzer, a sorting analyzer, you open SpikeInterface-GUI. When it's done, you save the curation format and you apply it and you get a clean analyzer. And again, you can open it and you get the clean version of your data. It's the main stuff. And this happened in 2 lines of code. So it's super easy to deploy at the lab scale. So very quickly, but you will discover this during the demo. I don't have time, Alessio. You tell me if I'm too slow. So it's a classical GUI you could expect from a cleaning to clean your sorting. It's quite similar to Phi, but so in short, you have all the classical views. You can see the template, and interspike histogram, cologram, spike amplitude, all that stuff. We have more dedicated stuff. We can weigh traces, trace map. You will see this density waveform. We have moving PCA and this quarter. So we have some specific view that I guess we have only us. The main important stuff is you will see view are linked. And the idea is you want to filter and to explore very quickly everything. So we made shortcuts, sortable stuff. It's easy. Well, something also which is important, you can see everything at the spike levels. And of course, our GUI play well with the sorting analyzer because you can recompute extension by changing the parameters. And of course, the main goals being, I want the creation format. The goals of this GUI is to make a file which is my creation. You will see this. So we have some plan for improvements. The main one you can remember is we are working on this, is to make manual splittings, and we are on it. If you have some demand, maybe you can make some question on the Q&A to make new features, but you don't know yet the features, so maybe wait the presentation. So now I will make a small demo with the historical app, which is a desktop app, and then I will leave Alessio present the web version of SpikeInterface GUI. And of course, just before starting, thanks a lot for participating to this meeting. We make an important survey. We could have asked, do you prefer Kilosort 2.5 or Kilosort 4? Do you prefer OpenIFES or SpikeGLX? But it's not so interesting. The main question is this one, and I'm super happy with the results. And thank you for voting. Alessio,
I'm not.
You are not, of course. Okay, and of course, well, here is the team. So we are lucky to be many to maintain this. It's amazing. I don't know if Zach is here. Maybe it could be on the stage or not. But well, we are many behind SpikeInterface, and we try to be friendly with newcomers and to debug the stuff. So here, the entire team. So Pierre also, which is not present here, and Zach and Joey are also heavy participating in the development of this. Et voilà. And something super important for us, mostly for Alessio, is to vote, is to be popular. So in short, if you go to the GitHub page of SpikeInterface and SpikeInterface GUI, if you click on star, then we have a +1. And it's important to make to apply for some grant or some maintenance to get some money.
Thank you in advance.
Thank you in advance. Et voilà. And that's it. I don't know how many time I have. Attends, I stop this. What? I think we are okay. So the main idea is I will make a small demo, some small demo on the SpikeInterface. So the first, I have an environment here. The first idea is how to start SpikeInterface GUI. So there are several ways. One is to use the console, where you install everything in a Python environment, which I have here. And we have a command line access, which is SCGUI. It's only this. And then you have to tell, I want to open this folder. In short, in SpikeInterface, we have our internal format. Let me find it. It's here in the demo. So I prepare some dataset for the demo, and a folder of a sorting analyzer look like this. It could look like a ZAR structure, but it looks like this. So here I have another analyzer. So to open, you just put SCGUI and the stuff, and you directly open in the console the GUI. Another way, which is super cool and which was done by Alessio a few days ago, is you don't tell which folder you want to open. You just tell a root folder, and then you have some kind of launcher which explore all the analyzer that are inside the root folder. And then you can only, let's click on this, and then you can also launch the GUI. So it's another way to open the GUI. But of course, because we are Python user, the one I prefer, of course, is to write a simple Python script, which is importing what I need, put my folder path here, load the analyzer manually using the SpikeInterface load sorting analyzer. I load it in memory. I don't need to load all the extension because my run main window will do it for me. I click on this, I have a console, and if I put some verbosity, it tells me how much time I need to open it. So many ways to open it. There's many options, command line, Python, you can do it several ways. So the main idea, And if you are a Spike sorting user, you should recognize the main concept. So here it's the desktop version. So you can change the layout by moving some stuff. Everything is dockable, so you can change the dock and stuff like this. You have some tabs, so it's really intuitive for user. You can even close some tabs and open it again. So there's many ways to move around the tabs. We have some preset for the layout. In short, this is the default layout. You could move some to other presets. Which is important, so you have many views, the unit list, the merge list, the trace list. All the views are linked. When you do something on a view, you will have something on the other view. For each view, it's important that you have settings. For instance, if you go here in the prop view, there's the settings. Show me the channel ID. Okay, so you have many settings per view. You should explore. There's no documentation of SpikeInterface-GUI. All the documentation is inside the software because per view you have a question mark that explain you more or less what the view is doing and what are the controls for each view. But the best to explore the software is not to read the doc, is to click on all the question mark everywhere. Okay, so let's start. So the most important view and the main one, of course, is the unit list. So it's super intuitive to see. So here I have 15 units. You have the unit IDs. You can see from SpikeInterface, which relate to SpikeInterface, and you have many columns. And the main concept is the unit visibility. In short, when you click on a unit, it makes the unit visible. And then all the views are changed on the, when you make something visible. In short, either you click on the visibility to open some stuff, either you double click, which make all the other invisible and this make visible. And there's many ways. Either you can select many, press space, either you can do control arrows. And then you can very quickly make some units visible or not visible. So this is the unit visibility concept that update all the other views. Okay, so it's quite simple. You can, of course, order, given some columns, by something. For instance, if I want to order by the Y position, if I click on this, I am at the bottom. So I can quickly explore from bottom to up all the units, or I want to see all the one at the bottoms. So I can do this, boom, and I select all the ones. You can do it per SNR. So you have many columns and you can sort by firing race or SNR. You have also some hidden columns. For instance, in this particular recording, I have properties, which is something attached to the sorting object, which is the result. I made my own property. I can make it visible, and it could be something that I made myself to pre-compute something or to help me. You can show more cells. So this is the unit visibility. Of course, the unit visibility can be done given other view. For instance, on the prop view, you can double click on a unit and it selects this unit. If you press Control, you can select more. And of course, you have more and more visible unit at the same time. Here you see a ROI, and when you move the ROI, this change the unit visibility. Okay, so the inner circle is the unit visibility on the prop. It's quite convenient because you can explore layer by layer your prop layout, and it makes all the units visible. Okay, which is this. So your unit visibility can be changed on the prop side, and you can see that everything I do here change it automatically also on the unit list. You also have a concept of channel visibility, so in short, which is the external circle. So the more channel I have, this changes view. And let me introduce the trace view. In short, if you have many channels, of course you have many, but sometimes you want to see less. In short, every units have a few channels around to describe the spikes, and it's what we have. So in short, we have a trace view where the number of channels can be controlled by this. And here you can see that we have a very fast, let's say quite fast, which depends on where your data is stored, way to explore the entire traces of your data. So you can, in this zone, walks through the entire stuff. In Spike interface, there's an important concept of multi-segments. And this is perfectly and then. In short, when you record the data, it could be in several pieces. So if you have two pieces, you have two segments, and you can very conveniently switch to one to other segments. One way to represent the traces, the other way to represent as a map, which is not, so this is the trace map. In short, this is every line is one trace. Okay. So for few channels, it's not super convenient, but you have also the trace map, which is the same. You can navigate the entire, and here you can see spikes, more or less. You can zoom in and out. You can check the question mark how to zoom in and out. You can even change the color, and you can revert. So depending the positive and the negative to explore to explore this. So you have trace map, trace. Let me introduce now the spike list, which is here. So when you select, let's say 2 units, let's say and you want to compare, we have a way to retrieve the spike from these units. You click on spike, and then you have all the spikes that could be millions of spikes, which are displayed in this list. Okay, some are from the first or the other segment. And when you click on a spike, we have a machinery to refresh the view. So in short, we have the channel visibility, unit visibility, and spike visibility. So when you click on a spike, it makes this spike visible. When you click on several spikes, you can see here that it's also I explain this later, change the visibility on some channel. For instance, if I go to the spike amplitude, I can select, let me select on the first. If I select many spikes, you will see that this spike will be selected on this. Okay. And the reverse way. For instance, I do this, I want to select this spike because the amplitude I don't understand. It's selected here and should be selected here. So you can select spike or units or channel the way you want, and it should refresh the other view, which is cool to explore at the spike level. And an important way, and something cool is that way, when you have a big unit, it's cool to check spike per spike to see that if it's stable enough in time. And it should be quite quick. It's the data readability is fast. In short, if it's a local drive, it should be fast enough. Okay, this is the spike. Okay, classically, we have the spike amplitude I just presented. So you can see one or several amplitude at the same time, which is super cool to check if you have some drift, if your unit is present along the entire recording. Something important is you can do it also for across segments. Okay, and here you have the distribution, which is mapped. We have many, when we are doing this, of course, we are subsampling the number of spike to speed up the stuff. So you can play with this number conveniently to have more or less spike display at the same time. Well, I let you explore the option for the spike amplitude. And the same way you have the spike amplitude, we have also the spike depth, just to check that you have motion a long time. So you can explore the spike depth just to check that if you have motion or if you have a drift, you could eventually correct for it with this view. Okay, so this is the amplitude view.
Sam, just a few questions. I think it might be a good
Let's make a pause for a few
answer
questions.
A couple of them.
Okay.
So someone's asking, are the keyboard shortcuts documented somewhere?
Yeah. For instance, here, press G. I will show it later. Press G. There's a bug. It's not long enough, but we have some press M to make a MUA. I will show it after in the creation mode. But not normally the shortcuts are in the question mark. Explain.
Cool. And how feasible is it to load large data sets with these views?
I will show it just after. The third demo is a large data set. It depends on the number of extensions. For instance, if you load the waveform extension, which is a big one, it takes time to load. So the main stuff is the loading from the disk to the memory. So if you have 2 gigabytes, it's the time to read 2 gigabytes. If it's local, it's quite fast. It's somewhere in the cloud, it could be more slow. So we have a way to not load some extension to make the loading faster. In short, the slow one is the waveforms and also the traces, but not the entire traces are shown. It makes the slower. In short, when I move this, the data are fetched on the fly. Here it's local, it's even more, it's simulated, so it's super fast. But if it would be a remote folder, it would be a bit more slower.
I think the other ones we can answer. So yeah.
Okay.
Thanks.
So I was presenting. And then classically, when you do what you want to check is the very often is the correlogram, autocorrelogram on the diagonal and the cross correlogram. For instance, if you want to check these 3-1, are they different? What you want to check is you want the dip in the autocorrelogram and you want to check that you don't have dip in the cross correlogram. It's an important check when you make the merges. It's one of the criteria to merge or not some cells. I will show it during the creation presentation. The cross correlogram, I guess you know what it is. The ISI, which is the interspike, I don't take too long to explain, but you can change some parameters if you want to recompute, for instance. So just to check the discharge of the Unix. Of course, it's simulated, so it like simulated ISI. We don't care. Voilà. Importantly, and very classically, you have the waveforms. So in short, when you want to check if 2 units are different, when you want to check is, are these 2 units different? So here you have the per channel. So in short, for every unit, we don't extract the template on all the channel. We do it for some channel around, which is known as the sparsity on the Spike interface side. So you have a sparsity. And here what we plot is the 2 nearby units, and we plot the channel. So we have several ways to zoom in and out. One is to zoom with the mouse wheels, with the shift or of the alt. Very importantly, you can overlap or not, or display side by side the 2 stuff. Merci, Alessio. It's incredible. You can do this. And the main idea of this is you want to discriminate, are these two guys different enough? It's the main question. Okay. The way I prefer is to show the same. So this is what we call the geometry. In short, you display the waveform where they are. In short, this big one is nearby this one. Another way, which I think it's better, is to display it flat. In short, you put all the waveforms flatly. And then another way to display is here you have the average, and you want to check that these 2 waveforms are discriminated enough. So you have the average in the middle, but more importantly, you have the standard deviation. And the standard deviation very often is more important to discriminate. And this is why here we also plot the standard deviation. And you should look very closely to the standard deviation. In short, to check that you don't have bumps, that your standard deviation is flat enough. It's a really important criteria for the quality of your sorting. So if you understand more this, so you can switch to this or this. I prefer this, it depends. Another way to see this, which is, so every pieces is one channel flattened together. It's what we call the waveform match, which is more or less the same. But instead of the standard deviation, what we do is to plot vertically is the distribution of all the spikes, not all the spikes, but many spikes. In short, you can see the distribution like this. In short, with the mouse wheels, you play with all the spikes, and it's some kind of top map distribution. And this is a useful tool because if you go to this channel, you see that the 2 waveforms are not discriminated on this channel. What you want to look is somewhere a channel that discriminates at the distribution level. So in short, you want discrimination enough here. So I think this is a cool tool. And here, of course, it's pretty easy because you have a big dip between the 2 distribution of these 2 beasts. So it's a new way of looking at I know that many tools like Phi are using to plot all the waveforms, but I think maybe this could be a better way. Okay. Very
So
quickly.
Sam, sorry,
Yeah.
one question was also what is the main difference with Phi? Maybe we can take this live.
Ouais.
I replied.
You
So it's
reply.
I replied. But basically, this I think it's more like it's highly integrated into Spike interface, and we have like as you can see, a core development team. So we are actually actively adding new features and improving this. While Phi, it works well with kilosort and EuroPixels data, but if you have like tetrads or other kinds of data, it might be a little bit less flexible. And then you'll see later that we can also run these as a web app. And I think this is like a killer feature as well.
Right.
But we can discuss maybe later
Mm.
at the discussion point.
So I
Sorry
will
to
finish
interrupt.
quickly the two last views I want to present. One, which is the PCA. So optionally, you can compute what we call the PCA, which is not so useful today with big data sets, but many people used to do it for small data sets with 32 channels, even more for Tetron. The idea is that you compress your waveform spike per spikes to reduce this to a few components, let's say 5 components or 4 components per channel and per unit. And then you get what we call the PCA. And the idea of the PCA is you have many. For instance, if you want to compare the two stuff, okay, it's a few PCA per channel. So depending on the channel, you want to play, let's say 5 channel or 4 channel, and you can decide 2 PCA or 1 PCA per channel. But even with this, you still have maybe 6 or 8 components, depending the channels. So how to explore high dimensionality? Either you go phase by phase, so PCA1, PCA2, PCA2, PCA3. It's what Phi used to do. But a better idea is to randomize the projection in many ways, or even to make an automatic randomization and to explore the high dimensionality like this. So you make your spike dancing. And the idea is you want to find an hyperplane, you can stop, where you can discriminate enough the two clusters. And by the way, a cool stuff is you can also select spike here at this level. So in short, if you select something in the middle, you have your spike here. But if you want to check why do I have this beast, very often you can see it's because you have a collision. So it's a way to detect, oh, my sorter detects nicely the collision because the point is outside. And lastly, it's the similarity. So here it's the similarity. We have several metrics for the similarity. And you have the similarity between all the units, again, all the units. So in diagonal, if you click, you select 1 unit. But if you click off diagonal, you can select 2 units. So maybe these 2 units have a high similarity. So here it's simulated. So it's not true. But you can click on some similarities you want to explore. Of course, this can be tedious if you have hundreds of neurons. So we have a better way to do this. You can have what we call a merge list, which is propose me some pairs that have a low similarity. And it gives you the list, and then you can click on this, which do the same. It gives me some low or some high similarity in the list, some kind of filtering this matrix to give me the pairs on this, and then I can explore it. Okay, which is the first part. And let me introduce now the demo 2, which is more or less the same. Okay, the only stuff I will do is to do curation equal true. So it's another data set, simulated again. But now I change the mode and I enter in the mode curation. Okay, it's pretty similar, except you have a new view, which is the curation. So by default, you have this. And also you have a new column, which is the quality. Okay, so the idea of the curation is to set manual labels, to make some delete, and to make some merges. So for the manual labels, you have these columns, and then you can go spike unit per unit, and you can select what you want. If it's a noisy or not, you can select the quality unit per unit. Okay, we have shortcut for this. I guess now M is for MUA, N is for noise. So we have shortcuts to make it quick. Okay, for also the first stuff is the quality in the curation. And then you can, of course, sort by quality to group all the good or all the noisy, so So it's quite easy to go back to what you did with these features. Another way is, let's say we want to remove small units. So I go to SNR and this one is too small. I want to delete. And I think you can press, we have a shortcut for it. I don't remember the shortcuts, but there's a shortcut. So here we want to delete a few units. And you see that all the units I delete are put in this
Control D should be
Control
a
D.
shortcut.
BIM.
Control D.
Okay. We have shortcuts. So the idea is you select units and they appear in the deleted units. It's something you want to delete. Of course, you can come back to check what is deleted and you can recover. So to remove from the deleted, to recover the unit and to put back in the list you want to keep. The same way, maybe you want to use the merge list, which is propose me some merges for some units you want to merge. So let's say, give me all the high similarity. Give me some merges. There's many ways to do it. The more simple is to use the similarity. We have advanced merges function in SpikeInterface. I will not present today, but here, for instance, I can check these two units have a very high similarity. And when you check it, you can see that on the waveform, on this, it's really hard to discriminate. And the spike amplitude, it's really like we need to merge this. So you can merge it with Control A, which is accept the merge. And you can see that in the merge group, you have this stuff. So you can go very quickly by checking many views at the same time and accept or not accept all the merges. And then you get this beautiful merge group. So in short, it's our creation format, which is the manual labels, the deleted, and the merge group. Then you can export to JSON. And you, my creation v1 JSON, and you can save it to a local file. You can check that creation v1. This corresponds with what we do. So if you go back, you see that this is our removes, this is our merges, and this is our manual quality we did for the stuff. So in short, the output of what I did is this file. You can also, which is something important, save this format in place of the analyzer, in short, in the folder itself, which is convenient when I do this. It saves somewhere in place, because if I close this, I can go back and open the same analyzer, which contain internally this format. And then I can continue or give the check to another colleague. The colleague can check what I did for the curation. And again, I will stop here. It's the main stuff, the main workflow we want to show to you is that the main idea is to construct this curation format. So you have your output data, which is the post-process, the sorting analyzer, and you construct this format with this GUI. It's important. So I also prepared two demos, but I don't think I have time to show it. One is to show a real data with NeuroPixel, which is local on my machine. So you will see that it's also work with local data. It's a bit slower because it's a bit bigger for the data. Okay, but it's still quite fast, even for exploring. Of course, the traces are read on the fly when I move this, so it's a bit slower. But selecting units or click one by one. And here in that case, it's a data set that is already created in my lab, so I can check that does the merges or the delete are okay. Just an example. And I don't think I have time for the other demo, but you can also load external data in the local mode. But I let Alessio to continue and to present the web.
Yeah, thanks. You guys see my screen? Yes. Okay.
Yes.
Yeah, so Sam presented the desktop application, which is based on Qt or Qt. And very recently, it was like a work from the last 2 or 3 months. We made a big effort in making the same GUI also as a web application. And I will show that it's actually pretty cool and it allows like additional workflows. So the first workflow is running the web app locally instead of instead of Qt. And basically, it's exactly the same. You can call the SpikeInterface-GUI. You can pass the path to the analyzer, but you just need to specify that you want the mode to be the web app. And instead of opening a new window, this will actually launch a server that renders the GUI on the local host. And then you just click on the link and it will actually render the GUI. So before showing the other two use cases, I want to show how the web app works. Okay, so this was already running. So here I'm in a folder and I have a few analyzers in SAR. And then I can just call SI GUI mode web. I can enable curation, basically similarly to what Sam has done with the Python API. And I will just open this analyzer2.sar. And you'll see that this will open a new window in my default browser. And the nice thing is that the two GUIs are basically the same. So the only difference in terms of implementation is how they render the views, but the backend, the machinery is the same. So if you try out the Qt version and then you switch to the web version, you'll see that they are very similar. So you have the unit list. You can easily check different units. Here you have the probe view. All the features that Sam showed are also available in the web version. We can scroll through the data. We can zoom in and out. We have the trace map and so on. So I won't actually spend too much time on this because you'll see that it's very similar, just a different way of rendering the GUI. Again, you have the curation, you can see individual spikes. Everything that Sam covered is implemented in this backend. So I covered this quickly because I want to spend a few more minutes showing two other possible applications of this. So maybe you prefer to have things in your local browser, but locally you can run the Qt version. It's fast. It's actually very performant. Also, the web version is, but there's no real difference. But having a web application allows something that you cannot do with the desktop application. So what you could do is basically launch the SpikeInterface-GUI on a lab server, and then you could have just one instance of the GUI running, and then multiple lab members that have VPN or SSH access to the lab server could actually connect to this instance of the GUI running, and each lab member could launch a separate version of the GUI on a specific data set and panel. So the backend that we used for the web development, it handles automatically these multiple users access. So one thing that is important, I have I will show an example of this, is that when you run this on your server side, so let's say you SSH in a lab server, then you have to start the GUI. We don't point to any data set because we want to launch it this launcher mode, but we need to tell basically not to use the local host, but to actually use the real address of the machine. So we have an option to do that is -- address auto IP. And so you'll see that in a minute, this will actually expose the real IP address of the server instead of localhost. So let's see how it works. So here I'm connecting to the VPN. I have a machine running in an office in Milan. And I open a terminal. I just SSH into my workstation there. If you're familiar with Linux, this should be no news. I also run a screen. So a screen is a way on Linux to keep a process running in the backend. So even if we close the connection, it still runs. activating an environment where I have all the Spike interface and SpikeInterface-GUI installed and the most recent versions. And then I just run that command that I showed before, SpikeInterface-GUI, mode, web, and then we just expose the address out to IP. And you'll see that this is launching the launcher version of the GUI, and it's exposing the address of my machine. Now, I close the remote, I close the terminal, everything, right? So this, thanks to screen, it's running on my remote machine. And I just open a browser and paste the link. So you see that now this actually is running on my remote machine. It seems it's running locally for me, but it's actually running remotely. So this is a path on my remote machine where I have an analyzer. And there's also an info tab here that you can basically review to see how it works. And then when I hit the launch button, this basically will launch one instance of the GUI on the data set that I pointed it to. So imagine one lab member, I just launch it on one data set that I just recorded. I check my views. This is all running remotely on my machine. So it's only rendering the visualization part on my side. And this is the good old GUI, as you will hopefully be familiar soon. So now let's imagine that another lab member wants to like open a new data set. Let me actually, let's assume I don't have VPN access on another machine, but I'll open another browser. So I'll open Firefox on this machine, just paste this launcher, and then this will render a new page. So now I can point it to a different analyzer 3. So these are all toy examples. Imagine these are actually sessions that you recorded from. We can change the displayed properties. So there was one question in the Q&A. So if I want to like add some additional properties that are available in the analyzer, I can easily do that by changing that list. And when I click run, it will launch a new instance of the GUI. This time it's a different data set. I mean, it has the same number of units just because we simulated it for the occasion, but it's actually a different data set. And then the other thing that I wanted to show, so the way that this works, so this synchronization between the launcher and the different views is that we actually embed some of the metadata that the GUI uses, like the display properties, the paths of the analyzer, and so on, within the URL. So this, like, it's universally pointing to that specific data set with the specific options that you asked for. And then finally, we can try another instance running. So now in this case, we have 3 different instances of the GUI running on the same machine. So mimicking having 3 lab members working simultaneously, changing some presets, disabling curation, you name it. And then this will open in yet a new window and allow people to work asynchronously and simultaneously on multiple data sets. Of course, if you have 50 people working at the same time on different data sets, you would need a machine with enough computing capacity. I mean, these GUIs, they do use a bunch of RAM and a bunch of resources to be performant in the visualization. But I think for a normal sized lab is a real game changer in using curation and basically providing the same platform for multiple users. Okay. And then there's another way that it's cool, and we actually use it at the Allen Institute for Neural Dynamics. So instead of using a lab server, we are hosting the SpikeInterface-GUI on our website. And here we can do that because at the Allen Institute for Neural Dynamics, all the raw data and the process data are in the cloud in S3 buckets. So we can access them directly from like web applications. And the other thing we did was deploying a custom launcher. So it's different from what we saw before, because we, in this way, we allow scientists to basically explore a database with all the spike sorted sessions and retrieve the post-process data in a session, and also launch the SpikeInterface-GUI similarly to what I showed you. So I want to show this live. So let me close some stuff. So this is on a ifis.alleneurodynamics.org. Here are a bunch of sessions. We can sort them by date. We can search. So our scientists are able to find the sessions they recorded. These spike sorted data. When I click on it, it will load all the post-processed streams available for that session. So in this case, this has two probes, probe A and probe B, but these are NeuralPixel's 2 4-shanks probes. So in our processing pipeline, we process each of the shank differently. And so you see that for each of them, we're going to have a different sorting analyzer in SAR. Then this opens a link, and then I can, it points to the S3 paths where the data and the recording is, and then I can click launch. And this takes a few seconds because now it's actually downloading the data from S3, but it's quite fast because now the server is living in the same area as where our data is. So it takes a few seconds. And here's the familiar GUI. So we have 95 units in this shank. And one thing that I want to highlight is that we can fully customize what we see in the unit list. For example, what we do in our processing pipeline is we use this automatic labeling. And so we have a property of the sorting, which is the decoder label. And so this can be SUA, noise, or MUA. And so this really helps navigating these views. So we can see that these are SUAs. They actually look like good units. And the other thing that you can do is also instantiate the GUI with like pre-curation. And this is what we did here in order to basically speed up the scientist's job. So basically first we pre-label the noisy units as noise, also in the quality. And also we, in the curation tab, we pre-delete these units. So the scientists can now just explore this like list of bad units and just confirm that these are actually noisy units, and then proceed with something that is a bit more interesting. For example, we could compute merges automatically. We see we have a bunch of units with a high similarity, so we can take a look. And this actually, it looks like, let me actually move the channels here. So this actually, it looks like a unit that might have been oversplit. Also looking at the cross-correlogram, which is a dip in the center. And so we might want to just merge this unit and so on. And the other thing that I want to show before finishing, but we started 3 minutes after, so it's okay, is that this in these views, we also have like access to the individual spikes for the different units. So we can load them. So this takes a few extra. Did I click on it or not? Okay, there you go. And so we have access to the traces and to the trace map. We should. I think maybe, okay, there we go. It took like a second to load. So we can see all individual spikes, and we can like explore the recording at different times. We can make these windows smaller. And of course, also in this case, each of these view is synced, so we can click on a spike at the very end, and the view should actually go there if it's been selected correctly. Let's see. Okay, so it went there, so we can see the individual spikes as well. So
Show
this
the
is
map.
one way to,
Show the
yeah.
map.
Yes. There we go. We can zoom in. And this is the last spike. Yeah, so this is just to show that this can be customized as needed, but it's very flexible. So we can add a bunch of information that we want. And this really like pushing the boundaries of manual curation. So all this data is fully remote and fully sitting in the cloud somewhere. And now we have like a centralized way to explore the data, perform curation, and also it's possible to add plugins so you can talk back with some custom functions to like databases and stuff. So I go back here, and I guess this is what we had, and we want to thank everyone for participating. And if you have some questions, we'll be happy to take them now. So let's see.
Even live, if you want to make a
Even live,
comment,
yeah. If
even
you want
live,
to
I
like
think we're
make comments, or if you want to even come on stage or ask a question,
we have the
let us
power
know.
to open your mic.
Yeah, I mean, we try to reply to all the questions as they came up in the Q&A. So I think most of it is answered by now. So let's see if there was something that we didn't.
Okay. No.
Yeah, in any case, so this kind of like we made like in the last few months a ton of development on this. So there are one thing that is like a planned new feature, and it's splitting. So splitting, we have an ETA, so we're finishing up some details. So by September, it should be fully integrated both in Spike Interface and Spike Interface GUI. And I think that is the missing feature, so that we have all the features that Phi has in terms of curation. So if you don't use splitting in your curation, then this is already ready to go tool. If you use splitting, you can still like start to like trying it out and see how it looks. And then once splitting is implemented, it should be straightforward to integrate it.
We have two questions,
So,
Alessio.
yes, one is if we want to keep both versions in parallel. I think yes, because basically the web. So now we made the effort to centralize the core structure of the GUI. So really, like the two backends, they only differ in the way they render the visualization, which is really minimal. Also, if you look at the code base. Well, not so many, but basically in relation to all the other machineries and signals and so on, we try to like make it as maintainable as possible long term. And I think that the Qt or the desktop app, it's still quite valuable if you run it locally, because the web app, it doesn't have the same flexibility of like moving things around and undocking things. So in the web app, things are this way. You can like choose before running it how you want to organize your views, but then you cannot move them around. So for example, if you have two screens locally and you want to split some views on the second screen, you can only do that in the desktop version, and there's no way of doing that in the web version. But on the other hand, the web version is really helpful for this kind of like shared and centralized resources and deployments. So this was from Tommy, and it's
One
done.
question about a bug in the remove artifact.
Yeah, can you please like
Chris,
ping us
do you have
there?
this in mind or not? Well,
Ping us, send us like a reminder.
Yeah, well,
And sorry about that.
we try it though. We try to fight bugs directly in SpikeInterface. Alberto, Chris, and
Yeah.
we try, but
So there's
it's hard to manage everything and at the same
so
time to
there's
improve.
another interesting question. Sorry. So for the cloud version, is there any safeguard to prevent two people creating the same sorting potentially at the same time and overwriting each other's progress? So yes, there is a safeguard, and the reason is that even if you open the same asset or the same session twice from two different users or two different browsers, it should start a different session. But now that I'm saying it out loud, it might not be the case because everything is embedded in the link. And just for you guys to be aware, this new launcher feature is something like quite new that we did like over the last couple of weeks. So there might be like some edge cases that we still need to like edge out, and this might be one. So I'm not sure. We need to try. Okay, if you have noticed
Great. Small question.
Yes.
Sorry, there was a question earlier that I thought might be good for everyone, which is like, how does this scale with the number of units? So if you have 1,000 units or several thousand, like what are the computational?
So at the moment, hundreds, it's working.
Hundreds is fine. Yeah, 500 is fine. If you have thousands, it starts to be a bit slow, but we've done a first round of like performance improvement, and I think like the next thing we need to focus on is to make it really scalable. So if you have like thousands or several thousands of units, maybe it loads some like subsets of units as you like scroll through the probe view or the unit view, these kind of tricks to make it scalable, because otherwise, of course, it's gonna be crammed with like a lot of views, a lot of like units in the probe view, in the PCA, and so on, and it might get slower. Yeah. There was another question, I think maybe Chris or someone answered that I saw.
No, I think we did creation.
Yeah, we'll publish a guide to set this up on a GUI server soon. Again, this was like relatively last minute, but it worked, and this will definitely make it into the docs. Give us maybe a couple of weeks.
And so there's a question from Elle who was that was the small question, which was if you're doing multiple sessions, what's the kind of workflow? Or say in SpikeInterface, if you combine two sessions together and sort it together, is there any way of like seeing where the split between the sessions are in the GUI?
Well, there is, if you have, I think the best way to do that would be to concatenate the recordings in case the sorter doesn't handle multiple segments. So for example, KiloSort doesn't, so you need to concatenate the recordings, run spike sorting, and then you could split the spike sorted data back to multiple segments. So basically telling SpikeInterface that it's true that you had like one concatenated recording, but it's actually two different sessions. Then if you compute the analyzer out of this multi-segment object, it will show as multiple segments. So you have a way to move over different sessions in the GUI.
Alberto made a really cool presentation, the multi-segment handling last year, and this video is available on the YouTube channel, just to check the machinery of the multi-segments, the many ways to do. Et voilà. No?
How do you extract?
No, there's no question.
Can you extract data from the windows?
No, not from the windows, but you can. The analyzer is the results, and from this you can export in many ways. We have exporter. You can even export to text or
you can
any
like
format,
download the curation.json or export
I think
it. So
here the question is to extract the spikes. The idea is you load back your analyzer in Python, and the analyzer have access to the Spike.
Yeah, no.
It's the idea. So there's an API. You need to have a bit of code in Python to make the spikes in the format you want. And the internal representation of Spike is quite efficient. So in short, the analyzer contains the spike in several ways, by dictionary or by two columns, or by the two at the same time, which is good for processing. And we have exporter to other data.
So there's another question from JT, and maybe like Chris, you want to take it since you're working on making the entire pipeline shank friendly.
Yeah, so the question is, can you handle multi-shank probes that were sorted shank by shank? And the answer is the GUI, yes, definitely can handle that. And SpikeInterface very soon will be able to handle that incredibly nicely.
Right.
But
And
the answer
maybe
is just yes.
there's a good practice to split by chunk to make the sortings. But if you don't have motion, maybe it's a good idea also to sort all the chunk at the same time with the same recording. So you have the result at the same time. It's bigger to explore, but it could be done in SpikeInterface. You have the two
Or
workflows possible. You
can
split,
spike sort by shank and then reintegrate into a single analyzer.
Yeah.
Follow up to multi-shank. How about 3D probes? Yes. So this it's an open issue. So we currently don't. I mean, we do have support for 3D probes. The problem is that the spike sorters mainly don't. So when you have 3D probes, for example, if you have like electrodes on different sides of one shank, the current recommendation would be to set different groups for these shanks, even because the probe itself, it's an insulator. So it's the signal from one side would be very dampened on the other side. So it's very unlikely that you see basically a unit across the shank. So effectively, this would be like different groups in the spec sorting jargon. Yes, for multi-shank, it would be also good. So another question is or comment is it would also be good to see multi-shank in one GUI because it would be interesting to see putative connection with CCGs between units on different shanks. Yes, I think it would be kind of hard to explore this at the moment just by looking at CCGs. But maybe it could be interesting to explore some additional extensions or functionalities to pre-process the cross-correlograms and find putative, excitatory, and inhibitory connections across your spike trains based on the CCGs, and then provide this information to the GUI and then use it as a visual feedback. But currently, this is not baked in, so I think it would be kind of hard and complicated to make sense of this just visually.
We could have a connectivity extension or something like this.
Yeah, but connectivity, it's a big
right, it's a big subject
field.
It's a big outside, but could be the idea is we have the concept of extensions that could be even living outside SpikeInterface itself. So you can make your own extension on top of the analyzer and save it inside. And of course, when you have the extension, you can make an extra view that use the extension to plot something, which could be the connectivity between subpopulations. Yeah. Not done yet, but we have plenty of time. Or not. Okay.
All right.
I think we can.
Yeah, if there are no more questions for now, it's fine, but please feel free to post some issues and please give it a try. We welcome feedback, and I think it's good momentum for this development. So we really encourage you to try this out.
Thanks a lot for participating. Thanks a lot
thanks
for
also thanks Chris
French
and Eberto for helping out in replying to all of you, and we'll see you around.
Salut.